Okay, so now let's talk about fluid flow where viscosity dominates. Okay, so examples would be thick honey, or thick oil, etc. Even lava would be fluid flow, basically, where viscosity dominates. And it turns out that let me write this down. This is too important. When viscosity cannot be ignored, Bernoulli cannot be used. Very important, okay? So, yeah, so you're gonna have to use a different set of equation, one of which is right here. So that's called Newton's Law of Viscosity. What does it say? Well, imagine that you have a fluid that's really thick honey, and now you have two plates, one that's fixed right here, and the other one that you can move by applying a force. So if the fluid is viscous enough, it turns out that the bottom layer here will always be fixed to the bottom plate, and this top layer here will always be fixed or stick to the top plate. And each lamina, that's what they're called, they're going to slide against each other. And of course they're grinding against each other, and that's why it requires considerable force to move the top plate. Well, how much force? Well, it depends on the viscosity here, okay? And it depends on the velocity of the plate and the distance between the layers. So let's solve a problem here, just to apply this. Here I'm asking you, what is the force on the small plate here that you need to apply to be able to move it 10 centimeters per second to the right? And here you're given that the distance between two plates is 1 centimeter. And we are dealing with water here. So right away, let's write the viscosity of water, which you'll need in your homework, by the way. That's 10 to the negative 3 kilograms per meter second. So if we isolate, the force required is going to be eta V over L times A. So this, when I put in the numbers, I get approximately 10 to the negative 6 Newton. That's the force required here, 10 to the negative 6 Newton, to move that plate like that, because there's viscosity in water. And remember, that's stationary. So right here I have pictures of demos that I will show you in the last lecture that we have. And these demos will serve to illustrate, okay, that when viscosity is important, it's extremely counterintuitive. It's absolutely amazing. Okay, so you'll see this on Monday.